discuss this topic, syntax directed translation scheme. And the initial part of syntax directed translation scheme, actually, basically it is the part of intermediate code generation where what we are doing, we are having that particular source code, and initially we have to convert it into tokens by using lexical analysis. After that, this token is converted into syntax tree, and then we have to apply semantic analysis, and we are just changing the particular code if the particular code have some of the semantic problems. And then after that, what we are doing here, we have to convert the source code into basically machine-like code, because it is intermediate representation of targeted code, where the hardware part will easily access the different codes. So for this, we have to discuss this. In that part, we have 3-address code, then different kinds of 3-address code, and why we call it as a 3-address, because it contains 3 addresses, 2 operands, 1 operator, and 1 particular operand is to store the value. If you are just think about the hardware part, where registers are there, their processing is only at a time they handle 1 operator with 2 operands. So if you are converting our expression into that part, so there is no need for your BODMOS things, means you have to just check the particular operators and different their priority order and find out which one particular part is firstly we have to calculate, then after that wait. So these particular calculations will be eliminated by using this 3-address code. So if we're talking about 3-address code, there should be some representation of 3-address code and types of 3-address code, which kind of codes you have to convert into 3 addresses. So if you're seeing that the basic part or form of 3-address code is equals to A equals to B operator C. So that is basically 3 addresses. A is 1 addresses, B is 1 addresses, C is 1 address, there is 1 operator is there. So if you are seeing the different kinds of codes, that is basically called 3-address code, like the assignment operator. If you're talking about assignment operator or assignment statements, it contains 3 kinds of statement. A equals to minus B, that is generated by unary operator, and A equals to B. So these 3 kinds of statement is called assignment statement. So in this chapter, what are the basically discussion part is that these kinds of statement can be converted into 3-address code. And for that, what we are using some syntax directed translation scheme through which we can convert such kinds of statement into 3-address code, because it is a collection of different statements like that. So that is assignment statement. If your second thing, you will see that conditional statement. If A, then B. So this is one kind of a statement where you can use this particular or convert it into 3-address code. Then unconditionals go to, if there are some condition, you can put up that. Then function parameter. Then array references. Then pointer representation. So these all are the types of basically 3-address statement where we have just defined some of the semantic action to convert these kind of 3-address statement into 3-address code, where we are getting every particular expression into these form. So if we're talking about 3-address code, how we can implement these 3-address codes? So the first kind of implementation is quadruples, triples, and indirect triples. So what is quadruple? Quadruple is basically, as name is suggested, it contains 4 things. So if you are converting any 3-address code into quadruple, what we are doing, there is a table defined where we have to just identify that there should be some arguments are there, some operators are there, and some result part is there. So what we are doing, we have to firstly convert the particular expression into 3 address code. So the first important requirement when we are going to converting the 3 address code or implementing quadruple triples and indirect triples format for that, firstly you have to convert the whole code or whole expression into 3 address code. So what is 3 address code? It contains 2 addresses for calculation, 1 address for storing the result, and 1 operator is there. So that is the most important part. So whenever you are implementing, because implementation is the part when you have converted already that part into 3 address code. So 3 address code will be converted, will be implemented by quadruple triples and indirect triples. So they are 2-step part. One step is what? Firstly, you have to convert the particular code into 3 address code. Then you have to, those particular code will be putted on the or converted for the implementation part, that is called quadruple triples and indirect triples. So if we're talking about, we can use data structures like quadruples, triples and indirect triples. These are the representation where we can easily identify the different arguments and their calculations, and the calculation again if needed, then we will use such kinds of things. Then quadruples, so quadruple is getting 4 fields. So there is 1 operator, argument 1, argument 2 and result. So if you are writing A equals to B operator C, it would be defined by quadruples. Okay. So what is the quadruples phenomena? Operator, field is operator, argument 1, argument 2 and result. So that is the format of conversion. Then instruction with unary operators will not use argument 2. So if argument 2 is not available, we can just leave blank as that, and whatever information is available, means every statement is converted into quadruple. There is nothing that is converted into the quadruple. And third, operators like parameter do not use both argument 2 and result, because if you are talking about functional call, definitely the arguments will be already assigned with 1 temporary variable, and that is in the part of 1, because 1 argument is there only for parameter if you are called upon functional parameter. Then conditional and unconditional jump, put the target label in the result. So if conditional or unconditional jump is there, then again you have to convert it into quadruple format. Then what is quadruple? We can try to understand. So there is an expression given, A equals to B star into minus C plus B star into C. So you can see that. So firstly, what we have to do, that is not converted directly into quadruples. So there is the role of 3 address code. What do you have to do? Firstly, convert it into 3 address code, and that is the primary requirement, so that you will convert the particular long expression. Because if you're taking this expression and directly you want to convert it into that, what do you have to do? Firstly, you have to find out the order or priority order of these operators, which particular operator is operating first, which was after that. Then you have to identify the operator, then identify their argument, particular operands. Then you have to put up into that table and generate temporary variables over there. Okay. So what you have to do, you have to convert this process, this particular 3 address expression, long expression, into 3 address code, where every statement into the form of 3 address code. You will see that T1 equals to minus C into the form of 3 address code, T2 equals to B into T1, T3 equals to minus C, T4, whatever code is given, that is in the form of 3 address code. After that, what you have to do? The table is generated because it is the representation of quadruple. So quadruple contains operator, argument 1, argument 2, result. Whatever argument 1 operator, you have to put up this minus C, T1. T1 equals to minus C. So operator is minus, argument 1 is C, argument 2 is blank, T1. Like star B, T1, T2. So this is the representation of quadruple. So if I am taking example, suppose X equals to A plus B into C by F minus D. So firstly, what you have to do, whatever priority order of operators you can, these particular operation you have to done when you are converting this into 3 address code. So the initial part is firstly operator B into C. So T1 equals to B into C. So that is 3 address code. Again, T2 equals to T1 star slash F. Again, T3 equals to A plus T2. T4 equals to T3 minus D. And X equals to T4. So that is the complete 3 address code for this expression. So that is mandatory to convert this into that. After that, you have to convert it into this. What you have to doing? You have to put up a star here, then B, then C, then T1. Then you have to put up slash here and here, T1 and F and T2. Then again you have to put up plus, then A, then T2, here T3 is there. Then again you have to put up minus, then T3, then D, T4 here. Then again you have to put up that equals to here T4 and here X, and this will be blank. So this is the quadruple. What is the benefit of this quadruple? The quadruple benefit is that whenever we need intermediate values for calculation, we will having these values into that. This T1, T2, T3, T4 is called compiler generated temporary variables. These are requirement based generation of temporary variables, and these temporary variables is scattered during the whole program till the need of these variables is required. After that, we will relieve these particular temporary variables, free that temporary variables, but the value is also removed from that. But still, if you are requiring these values, all T1, T2, T3, T4, whatever intermediate value you have calculated, not exactly the final value, you will be getting through this quadruple. But what is the disadvantage of that? Because it consumes more memory, because you are every time defining this compiler generated temporary variables. So that is the part with the quadruple, and this is the disadvantage of quadruple. But when intermediate values are required, quadruple is very beneficial. So according to requirement, these particular formats are used. Then if you are talking about triples, so for same expression, in triples, what we are using some pointers variable, and these pointers variables are temporary. Whenever we are storing that value for calculation, at that moment it will store. After that, the pointer variable will relieves. Means you cannot use the intermediate values if it is required during the program. So you can getting the final values until the time final value is stored, but in between whatever calculations you have done, that is not stored by these triples, and that is the advantage for that, disadvantage for that. But this is memory efficient. It will take lesser memory because there is no need to define all the temporary variables. It is pointer variables which relieved after the calculation of the particular part. So if you are seeing this consideration, that is the 3 address code for that. And here only 3 part is there. That's why it is called triples. Operator, argument 1, argument 2. These are basically these are temporary pointer variables, and that would be released. So if star B is calculated with 0, B star 0 will be calculated, then this particular 0 will be released, minus C if equals to 0. When minus C is calculated, when star B with 0 is calculated, the 0 is relieved. Likely we are using, and finally we are getting the 4 value equals to A. Whatever value 4 is that will be stable in the form of this A. So A will store the value, means this is used for calculation. But the disadvantage of triples is only that if we cannot use the intermediate values which is calculated in between. So that is the difference between quadruple and triples. So what is difference? Quadruple is having four particular parameters. Triples is having 3 parameters. Quadruple is having compiler generated temporary variables, that way using more memory. Triples is using pointers variable, that's not there, using more memory. But if intermediate values are required, quadruple is better. But if it is not required, then triples is better because it will provide memory efficient approach. Now how we are representing this particular part? Basically this is array references, xi equals to y. So if we are defined, because you have seen that here one array variable, there is yi is what? This is array variable. The value of array variable is assigned to single variable. Here what? The single variable value is assigned to array part. So both the statements are different because here you have to calculate the position where to store the data, and that calculation is doing with the array pointers. But here single variable is there, the location you have to find, picking the value and store that. So both the particular part is different when you are going to calculate. And for your knowledge, this particular part is only used with triples representation. That is memory efficient requirement is there because only the calculation is done over there. So no quadruple is required for that purpose. So if you are seeing the first part xi equals to y, you will see that. Firstly, operator is what? Because we try to finding the location of xi because y is stored the value and that value is directly stored to that. So there is no need to calculation for y. Where is needed that calculation? That calculation is needed over xi. So what we have to do? 0, the operator is this array xi, and then after that equals to 0. This 0 value y equals to xi. So xi is stored in here. If this particular part is there, although we are calculating this right hand part first because this will be the part where we calculate the value or finally this value is stored into that. But here this is single variable. So value is stored. Where we need calculation? Xi. So xi is initially calculated. Then the value of y is already there. Value of y is assigned to xi. But in this case, there is difference. Yi is there. So firstly, yi is calculated. And here we have to put this also. That is important part. That is missing here. That is equals to this and equals to this equals to that. Means firstly you have to calculate this. Then equals to part is working. Here equals to part is working, then calculation is requirement. Means this value is firstly taken, then we have to calculate this part and this value is stored in that. So slight difference in that. So for these kind of representation, triples are very suitable to provide or compute the value of array references. So it is very good to use triples for array references. Now if you are comparing quadruples, triples, there is another, talking about, there is another structure which is not given in this PPT, but that is basically called indirect triples. Indirect triples. Because it is very lesser use of indirect triples. That's why we have not mentioned over here, but I am giving you some idea about that. What is indirect triples? Indirect triples is basically the triples which really works like quadruples. Because in indirect triples, if you needed to use the intermediate calculations for further calculation of the program, then what you have to do? You have to just store the intermediate values in triple formats by using indirect triples. What is added for that? That is also complex. What we are using 2 pointer variables. So initially the triples is defined by that. What we have to do? We have to store these particular parts like 0 and 1. So we have to make another table where here is the statements and we have to put in some new pointer variable for storing that, like 0 and 1 is there. What we are putting? 13 and 14. So 13 and 14 will store the value of 0 and 1 and it will provide these two intermediate values whenever required for any computation. So that is the benefit for indirect triples, but it is more complex because if you are using 2 pointers variable, the complexity would be more. That's why we preferred quadruples. So indirect triple is a kind of option for quadruples in the form of triples, but it is very lesser use. So triples and quadruples are more used. Now if you are comparing, I have already told you that quadruples requires many temporaries because you have just stored these these intermediate values also if you need it for calculations. Triples requires fewer temporaries. Temporaries are implicit. Why it is implicit? Because that temporary is only used, pointer variable is only used to compute that value and at that time store this value for the purpose of that. But after that, when this calculation has been already done at that moment, the particular value is released and that pointer value is also released. Second is easy to move around instructions. So in quadruples, because everything is available, so no instruction is need to worry and everything will be calculated by that. But in triples, sometimes if intermediate values there are, sometimes more complex values are there. So you have to every time call this pointer variable and pointer variable will be uses, and same pointer variable might be used for storing next particular value. So for this, implicit reference need to be updated if instructions are moved around. If same instructions are there, might be you will use different pointer variable. But here there is no need. If T1 is defined B plus C, then whenever B plus C is calculated, you can use T1 value directly. Okay. So that is the difference between quadruples and triples, and these are very important structure to convert the particular expression into 3 address code and further assess for the targeted code. Now that is this production is given, and that is a kind of assignment statement. So that would be basic method how to convert the any particular expression into 3 address code. So this is the production given, S produces ID equals to E. So this is basically used for assignment statement, where whatever value you are calculating, it would convert into a single value, but that single value may come from any calculation or directly assign the value. You cannot differentiate both things. Okay. So whatever final value is calculated, that would just having this ID. ID means a single value, but this single value is either a single value, base value, raw value, or it comes from a long calculation of the particular expression. That would not be clear. So the final statement in assignment statement, S produces ID equals to E, will just intimate that there should be some expression is there that might be come from this calculation or directly assigned, but this is the final value of this whatever expression we are going to calculate. So E, that particular variable where value is stored, ID is the value which is calculated from previous particular expressions, and S is the basically that production which intimate all these values. So this is kind of assignment statement. So here what we are using different semantic actions, that is E.addr. addr means address plot. We are using dot place also. If you are using .addr, might be we are using somewhere it is dot place. What dot place? Hold the value of expression E. Can be a name, a constant, or a temporary. So these are the difference. Name means single variable is defined. Constant means there should be some value that is directly given in terms of constant, and temporary means it will be come from some calculations. Then E dot code, sequence of 3 address statement that evaluates E. So dot code is basically used for string value translations. We are using some strings, some particular variables. So string value translation will be called E dot code, like E1 plus E2, E1 dot code, E2 dot code. But it is further calculated into capital E. So it is called E dot code. Then S dot code is scores the 3AC for statement S. S is the final value, whatever expression is given, like this expression. So small a is the final particular variable which stores the final value which is calculated by the right hand side. So that is. Then generate. Generate is a very important function, because if you are not using this generate and we are trying to write the 3 address statement or semantic action for any particular kind of a statement, it will be very tedious and lengthy. So what we are doing here in this particular book or in this particular part, there should be a function generated. So generated function is what shows that easily convert the particular part into 3 address code, and whatever address code and these kind of semantic actions will be involved with these variables, that should not be shown by using this generated function. So this function helper to create a 3 address code instruction. So if you are writing any particular part using generated function, it would be very easy to represent that in a very single format. So generated function is already having such kind of codes where every particular argument, operator, whatever information associated with that, these all are assimilated with the part. Now like this, E produces ID, the single semantic action that is translating expression. Basically this is assignment statement for assignment statement. So E produces ID. If you are writing in this form, E.address equals to symbol top. Sim top points to the current symbol table where it is stored. Sim top dot get ID comma ID dot lexeme. Lexeme means this is base value, because this is whenever you are defining any A equals to suppose B into C plus D. So what is the value of B is B naught, C is C naught. D is D naught. Sometimes it is updated, then the value is there, but base values are B naught, C naught, D naught. So B naught, C naught, D naught is basically IDs. IDs means the raw value which we have taken. So the address part will just use this id.lexeme. E.code equals to null. Why it is null? Because it is not a string valued integer. It is not having some calculated value. It is direct value. Means when you are putting this A equals to B into C, like if you are writing T1 equals to B into C, and we have just made a particular tree. Here is star, here T1. B is what? ID1. C is what? ID2. So if you have seen that ID1 and ID2 is raw values, that is not calculated from any part. So what we are using for code, it is null. What we are using for address, it is directly taking id.lexeme. You can also use for that, this part is also used. So here E dot address equals to simply E dot code equals to E dot place. Sorry, 1 minute. If you are writing this code, so E dot address equals to, simply you have to write here id dot place equals to E dot place, and then again id dot code equals to E dot code, because this value comes from here. If you are using this would be much easy. So E dot code equals to generated E dot place E1 dot address plus E2 dot address, and here also E dot address. So that what shows, basically what shows, if you are using generated function, we don't need to put up the value of E dot code also, how which type of operand is there, what are values are there. That is not needed. We are just using generated function, and by using this generated function, E1 dot address means it is kind of a variable that should have semantic accent of dot code, means it is a string value translation. Might be this even values came from any particular calculation. Okay, that should be happen. Might be it is a single value. Okay, so dot address will just show that it is a raw value, but dot code will be embedded in this generated function. So this is the benefit of generated function. Now if you are seeing that is given s dot code equals to E dot code generated simtop dot get id dot lexeme equals to E dot address, because E is the variable which is came from the calculations. That way address, E dot address means this shows the location of E. ID, because it is single variable, single value, so that is shows by lexeme. E dot code will be show this thing. Now E1, E produces E1 plus E2. E dot address equals to new temp. So what we have to do, if you are any intermediate representation, like I am telling you, if you are writing this, okay, so we try to calculate this. What we are doing, T1 equals to B into C. So what will happen? Firstly, we have to create a new temporary variable, because multiple expressions are there. We cannot directly use that. Okay, what we have to do, firstly calculate it, then that calculation is stored into temporary variable, and this temporary variable will be converted into capital E, which is again used for this expression, that is T2 equals to, then again temporary variable is there, T1 plus D, then again temporary variable is there, A equals to T2. There is not needed. So such kind of operations will be solved by using generated function. Although it will given all the information, if you are using generated, that information is not needed. I hope so. Here it is given, but that is not needed. We have to put only this. If you are putting only this, so that generated function already embedded these such informations. But here There are two types of translation schemes. One is abstract translation scheme. Second one is concrete translation scheme. So if we're talking about concrete translation scheme, the concrete translation scheme only having this part by using this generated function. But if you are using abstract translation scheme, you will show all these that. So there is no need for that. We can just ORing this e dot address equals to another operator. So this particular part is written in abstract translation scheme. This part is same, e dot code, e1 dot code, e2 dot code. These part are same. But if you are using abstract translation scheme, this part is written as this form, e dot addr, then equals to, then e1 dot addr plus, then again e2 dot addr. So that is basically the abstract translation scheme. That is not concrete translation scheme. That is abstract translation scheme. Concrete translation scheme, directly you can use this. This temporary variable is there and you can use this part. So if you are converting it into concrete translation scheme, the size of semantic action will be very less. But if you are using abstract translation scheme, you should completely show this. So these two kinds of representation we will use in representing semantic actions, but generally we have to use this for one particular application. After that you will be getting that such kind of thing. This is abstract translation scheme. Then what you have to do? Again, you are using concrete translation scheme when you are aware about generated. So this is the syntax directed translation scheme for translation and assignment conversion into 3-address code. So next time I will discuss the further statements into that part, and we will having some beautiful sessions for understanding this 3-address code. Thank you very much.